Yep, perfect.
All right.
Thank you.
So thanks for having us. I'm Matt Adams. I'm a professor at New Jersey Institute of Technology. Since you're all on the other side of the world, I figure I should give myself a little bit of an introduction so you know who I am. So I oversee the Materials and Structures Laboratory at New Jersey Institute of Technology. We are based, about 20-minute drive outside of New York City. So we're basically in the New York City metro urban area. And our lab focuses on concrete materials, cement-based materials, long-term durability, and sustainability issues associated with that. I also do a lot of work looking at how we can connect fundamental science to field use to policy and legislation. And so that connection in that area that I work in is one of the reasons why I ended up being asked by ACI to chair the low carbon code committee and help push this through, because I was very familiar with the range of policies that have been put in place in the US, which was sort of the impetus for us to develop this. Is there were all of these policies being developed sort of scattershot across the country and really around the world. And so we wanted to try to provide some better guidance. So I'm not, since you're a sustainability working group, I'm not going to go over all of the embodied carbon emissions things. I assume most of you are familiar with that. But I do want to take a second to just sort of define low carbon concrete in a more generic way, right? Low carbon concrete is a performance requirement that's going to be set by your design professional. And right now, it's mostly based on reducing the global warming potential of the concrete below a particular threshold. So in order to define what low carbon concrete is, first you need to set a benchmark. So you need to know where you are in terms of GWP right now. You need to just determine your desired reduction or limit, and then you have to design to meet that desired reduction, right? We see in the US, there are a number of benchmarks that have been developed. The most commonly used one right now was developed by the National Ready Mix Concrete Association, which is a trade organization of ready mix concrete facilities. And they used data from their members to essentially create benchmarks for different regions of the US. This is now a couple of years old, but this is what we ended up using as a standard in the code, but we'll talk about that later. But even within this, like, the data is too broad. It's not focused enough on certain areas. It's something like 65% of the data used by them came out of either New York City or LA, right? So that's not really necessarily representative of the entire country, and some of the like north central areas had very few data points. So like in the middle of the country where there isn't nearly as much construction. So benchmarks are actually really difficult to set. I'm sure I was reading your guide that you put out. I'm sure you're aware of that. How do we get to low carbon concrete, right? It's a design goal. It's a performance requirement. A lot of times I get asked, I'm sure you get asked, what is the concrete mixture I should use, right? But it's not a single mixture, it's a design goal. And there's lots of different ways to meet that. And so it's really going to be subject to what you have available locally, cost requirements, and what your engineers and contractors and labor can actually work with and what they know how to work with. So for that reason, our code does not focus on telling you how to make concrete. So the code does not say you can or can't use certain materials. The code is really set on helping you develop that GWP limit and figuring out what that number should be that you can then specify for design. So when we talk about getting to low carbon concrete, right, we have all of these solutions out there technologically, but we're not necessarily using them. Of course, there's new ones being developed all the time, but we still have access to a number of things, but we're still not doing it. And why is that? First, of course, there's a fear of cost, right? That these new materials, new ideas are going to cost more. Some of them do. A lot of them, if they get to market at a scale that we actually need for concrete, are typically reasonably priced. Where the cost really comes in is that knowledge transfer time period where, we screw up in the field and we have to take things out, or we're spending a lot of time as designers in the office reading that we can't bill to clients, et cetera. So all of that training costs a lot up front. For concrete manufacturers, there's space and capital issues, trying to work with multiple materials now, and where do you store them and how do you mix them properly? Here in the US, we use very few pre-blended systems. All of the ready-mix contractors like to blend themselves at their plants. So then they need to have silos of all those materials. Moving to anything new obviously gives us a lot of risk and liability concerns, particularly when you don't have code provisions to fall back on and other things that you can say, look, I'm following what the standards are requiring me to follow. But of course, all of this can be handled with political will, like getting the right policies in place, getting the right legislation in place, getting the right codes in place. And so that is sort of the impetus for a lot of the policies that have been developed in the US, and then ultimately the code, because when we have a code that we can point to as a requirement, it makes it a lot easier to sort of overcome these other items because now they're being forced to do this. But when we look at policies around the world, in terms of legislation or just agency policy or actual code policies, there's lots of differences in the way people are working with low carbon concrete. The way they're setting benchmarks is really different. What they are setting for limits is really different. How do you calculate whether there's incentives or no incentives? There's really a big difference there. And here in the US, it's done on a state by state and even city by city level, which can be really confusing for the LDPs that are typically working in multiple states at the same time. And so that's difficult. And then a lot of the code provisions or that have been put into policy have been proposed by environmentalist groups that don't really understand where we are technologically with concrete. And they are actually trying to get provisions into policy and legislation that are unattainable with current technology and not really something that is possible. And when you do that, of course, policies get ignored and nothing happens. So it's really important to kind of balance where we need to go with what's possible. So all of this got us to putting together this code, which I was honored to ask to chair this committee. This is our group of folks that put this together. It was a very dedicated group of 15 or so people. And we were able to write this and get this published and approved in about 18 months. So it was very quick, but it's a very small document. If you actually get the document, it's only about 24, 25 pages. It's been out for a year now. It's really, in terms of code language, it's the first of its kind in the world. There's plenty of policies and guides that have been written, but in terms of actual mandatory language, this is the first one. And what we're really doing is providing the designers with a method of setting your global warming performance requirements. So what is that number that should be met? The way that we do this is different than what we're seeing in a lot of policies that are being put forward. Many policies that we see are focused on carbon limits per each class of material or each type of mixture, right? So your 30 MPa mix needs to be, all of them needs to be below a certain GWP threshold. The difficulties with that is it restricts some flexibility in the overall design. It also can lead to increased volumes of concrete because people will lower the GWP, maybe get a lower strength in there, and then increase the total volume of concrete that they're using to meet structural requirements. So because of that, we wanted to look at a whole carbon budget for a whole building, but of course that's really difficult when you have a scope of only one material. And within ACI, we're concrete, right? We can't set code limits for doing a whole building or whole project lifecycle analysis because that necessarily involves other materials. So what we decided to do was this weighted carbon budget. So basically where we're using carbon limits as somewhat of a benchmark, but we weight all of that by the volume, and you're actually allowed to use some mixes that would be over your limit and some that would be under. And as long as you're balancing and your total average weighted average is below that GWP limit, then you meet the requirements. And this is a way that we were able to cover more materials, not have to allow exceptions for high early strength, because we see a lot of policies also saying, oh, you can increase your GWP by 30% if you need high early strength. And then the designers just say, well, everything needs to be high early strength, right? So trying to avoid some of those loopholes. Our code is also only focused right now on A1 to A3 stages, so the raw material extraction up until the concrete leaves the ready mix facility. Again, this is because this is where we have data. This is where EPDs are available. We don't really have the standardized tools for the rest of the life cycle at the moment. We would like to get there with concrete. I think you all probably know that, right? Concrete shines as a durable material. But in terms of having the right tools to do it, we're just not there yet. Our framework, when we were putting this together, right, we were starting on a blank page, so we were trying to figure out how to do this. So what categories do we need to use, what methodologies, and what were our requirements, and then most importantly, our exceptions. So this is the outline of the code. What I really want to point out here is that the meat of the code is in chapter 4. This is where all of our calculations are. The first 3 chapters are really about scope and how you can use it and just some references. The last 4 chapters are essentially copies of each other that have some specific limits for different types of projects. This is basically set up because in the future, as we expand on this code, we expect to see differences in the way certain things need to be handled for certain types of projects. But this first version of the code, essentially, it's the same thing for all of the project types. And then we have an Appendix B, which is examples and documentation. For you guys in Australia, Appendix A, you'll just ignore it because those are the regional benchmarks that were available for the US. And so we published those in there, but we'll talk about that in a second. In terms of scope and adoption, this code can really be adopted in many, many ways, right? It can be adopted in just a code book. It can be referenced by a designer as something that wants to be followed, or an owner can require you to follow it, right? So this is pretty standard language in codes in terms of how they can actually be used. What do we apply to? We really apply to everything that involves concrete construction, including repair and rehabilitation. What you'll see though is that the code, what triggers needing to use set limits is the amount of concrete that you're using. And so you're only thinking about the new ready mix concrete that's being applied. And so typically, unless you have a huge repair job where you're using a lot of ready mix for repair, you're not going to really trigger this code in repair and rehabilitation at the moment. For the most part, you're only going to trigger this in new construction. So let's talk a little bit about exceptions. Right now, we don't cover precast, we don't cover tremie, auger cast, and shotcrete systems. And then we also don't cover pavers and masonry units. Pavers and masonry units are really outside of the scope of ACI unless there's an agreement with the Masonry Society. They own the code work for for the prefab block systems. Precast and these other materials, we just don't have the right data to be setting benchmarks yet for them, and they are significantly different in terms of their requirements for mix design that we didn't feel comfortable lumping them in with everything else. The code is also limited to a mid-range normal strength range of concrete at the moment. Again, same problem where we just don't have the data in general around the world to be setting benchmarks for concrete outside of this range. That's not to say that if you were to adopt it yourselves and you had the data that you couldn't remove this exception, right? And you just have the benchmarks that you want. So Kerry will talk about that a little bit, the ways that you could try to use the code and change it how you want. In terms of benchmarking, what should you use, right? Benchmark, you've developed this in your document. I went and looked at it. This value for us is going to be a moving target over time. It's likely going to, hopefully going to reduce over time. But the key point here is that benchmark is not a minimum standard. It's just what we want to compare ourselves to. And we always want to, in this, we really want to be consistently trying to reduce carbon over time. What the code states is for benchmarking, you should really use your own benchmarks. You should use local data, develop your own benchmarks, set limits that make sense for you for locally available materials, right? So I went and looked at your guide to low carbon concrete. You followed a similar tool that GCCA put out in the UK, and you could use these as your benchmarks, right? And you could choose one of these lines as the benchmark that you want to set, and then set a limit based off of that. So you already have that there. I would recommend, because it appears to me, and you can correct me later if I'm wrong, but that this is for the entire country. You may want to look at how, you may want to start to think about looking at it on a more regional basis, because I'm sure you're a large country like us, you have regional variations in what types of materials are available and what standard practices are. And we really spent a lot of time looking at that. And we wanted to make sure that, we weren't overtaxing companies that are just still trying to figure this out in parts of the US just because New York City is way ahead of the curve, right? And so that's one of the thing. Oh, I see, that's guide version 2. Great. In terms of the limit, the only limit that the US that we're setting in the code right now is if you're using the NRMCA benchmarks, the national ready mix ones that are only useful for the US. And we say that you need to use a 15% reduction from that. Since you wouldn't be using those, you should set your own reduction value as well, based off of, again, what is a viable solution for you. This 15% number that we came up with was what the committee came to consensus on. It was not unanimous, right? But it was a discussion, and it's what the majority of us felt was possible in the majority of the country, right? So we know that that's not necessarily always going to be the case. There are times where that's not going to work. So we also have caveats in the code where you can speak with your code official and kind of write up a document that says, look, we don't have, in this particular area, we have no access to SCMs for whatever reason. So we can't meet this code requirement. And then you can get a waiver for it. And so that's all written into the code to allow that right now. In terms of limits and what we actually need to do, we've based this off of essentially the volume of concrete. So this is from chapter 5. So this is looking at a building, and we set it up slightly differently for different sizes. And this was because we want to be cognizant of the fact that this is new for folks. It's going to cost money for them to figure out how to do the paperwork and the documentation. And it's likely going to cost a little bit more money from the materials side just because the ready mix plants are figuring out something new. So with that being said, what we set is we set a GWP project average needs to be less than or equal to alpha of your benchmark, and alpha would be your reduction number. So for us, our alpha when we're using NRMCA is 0.85. But again, that number would change for you. And we only require that reduction when you have a building that's over 4,600 meters squared gross floor area. So the largest size projects. Medium-sized projects, you don't have to meet a limit, but you do have to report what your benchmark average would be and what your project average would be. So you still have to go get the EPDs. You have to go through the process of getting all the documentation, but the code doesn't actually require you to do that, to set a limit. And then the smallest buildings are really, you just need to write a little document on what you have done to try to reduce carbon emissions. So just trying to get people to start thinking about it. But this is really because we didn't want to see, local homeowners that are casting a new basement having to pay increased prices for, their local mom and pop concrete producer for this new code. So likely this will go away over time and everything will have to meet this. But for this first version, we're trying to be cognizant of rolling it out a little slower. The process for us is you're going to choose your project type. And then there's a compliance path that I just showed you that's based off of the size of the project. And then you try to meet your requirement. And the main documentation is that calculation, getting your GWP project average, your benchmark average, and then determining what your reduction is. And then you have to also provide the EPDs to go with it. In the code, we also allow you to not use an EPD and just use an LCA. And this is, again, because there are parts of the country where concrete plants don't have any EPDs yet. And so it takes time to develop those. And so we're letting people kind of use a more preliminary tool. Again, likely over time, hopefully that will go away and it'll just be EPDs. But we're just trying to be cognizant of all of that. So that's a basic overview of the code and kind of what we're trying to do. If you look my name up on YouTube, I've given similar versions of this presentation several times, and there's one or two out there that have examples, but we just didn't have the time to get into those today. But there's a couple of presentations out on YouTube on 323 that dive a little bit deeper into it. But now I want to have Kerry go into that stuff. Kerry, do you want to take over, or?
Do you have the slides there? I do have them.
I do have them right here, but it might be easier for you to take over.
Okay.
I couldn't combine them.
Did I just grab them? So I have it on my, can you guys see? I'll put
it
in
it's not full
presentation mode. Okay.
There you go.
Okay, I can't see. So just to introduce myself here real quick, Kerry Sutton. I'm with the American Concrete Institute. So I am a code advocacy engineer, but I also wear another hat there. I'm just recently become their executive director for their Center of Excellence for Carbon Neutral Concrete. So this is kind of a new position for me, although I've been supporting this Center of Excellence. So if you're interested, take a look at our website. This is the center also supports a lot of work that Matt does and the committee has done within ACI organization. So I'm just going to move through here on the presentation. So just a little background on ACI I wanted to give you to kind of dovetail with the good work that Matt and the 323 committee has done. As he mentioned, this is the first that we know of code specifically to address low carbon concrete. So we're pretty proud and happy with the work that Matt and his team has done. So ACI is a large organization. I don't know how much you all know about ACI, but we have over 10,000 members worldwide. We have hundreds of committees. We have over 30 codes, specifications, certifications, a lot of things. So this code was very unique and for the sense that we're addressing a really immediate need, right? Low carbon concrete, it's something that we felt, the Institute felt was really important to do and that we needed to be the leaders on this. So we do this in consensus process. We had a lot of stakeholders that come in and help us develop our standard, as particularly this code. So it's something that it's not a small effort, as Matt can attest to, but we're really proud in it, and it will evolve. It will change over time and continue to even reach out to more folks. So again, ACI members, we're a lot of different folks, engineers, architects, educators, a lot of people come together to develop our codes and standards. So the first thing when we develop, especially a new code like this, and we've had 3 or 4 new codes in the last couple of years, is education. This particular code on low carbon concrete is very specific, is that it's going to reach a real need with a very specific audience. Many of our ACI professionals, many of our design professionals and folks that we work with are not as savvy on dealing with low carbon concrete issues. So we realized, Matt's committee realized, there's a lot of folks that need to get educated on this, and I'm sure you all understand that. The design professionals, the architect community is probably way ahead of most in the United States as far as the users of this type of a code. Contractors need to understand what this means. They're going to be living this code where and when it's adopted, right? So we have a great need of education with contractors. Our concrete producers also need to be educated on the aspects of this code, and building officials. So in the States, and I'm sure in your country as well, those that actually enforce codes, right, out in the field when something is in place. So a lot of education. So immediately a year ago when this code was released, we put in a kind of a big campaign to try to hit many different types of groups to start education. Because if people are going to adopt and use this code, they need to understand it. And so as Matt has mentioned, he's been giving probably dozens and dozens of presentations. I've hooked him up with a lot of folks, and he's done a lot on his own. But these are some of the key groups we've identified that really need to understand if you are going to implement ACI 323 in this type of a code. So,
Hey, Kerry,
yes.
you dropped out of presenter mode. I don't know if you want to reclick that
Okay.
button.
There we go. You guys see that again? Got it?
Yeah.
Okay. All right. So continuing on, just in the U.S., our next step, second to education, is our priority is to get this code adopted. Right? We want people to use it. We want it to be out there and usable. So for ACI, at least in the U.S., and I'll dovetail with some of our international efforts, is the model code. We want to get it into in the model code. So in the U.S., our states, our jurisdictions, there is no country code that's required, but jurisdictions can adopt model codes, right? The key model codes in the U.S., and many of you may know this or may not, but is the I codes, ICC, International Code Council, and the National Fire Protection Association. So these are two areas, two standards, organizations that ACI generally works with and has their codes adopted in. ICC is probably the biggest one. So we work in general with ICC, and we want many of our codes, including this code, adopted within the I codes. So how that works, this is kind of just a depiction of all the different I codes, the International Code Council codes. There's a building code, there's an existing building code, there's a residential code. But where we feel and what we've been trying to work with is ICC has an International Green Construction Code, or the IGCC. So they have a subgroup that they work with called ASHRAE, which kind of oversees all their energy and environmental aspects of the code. So right away, we began working with this ASHRAE committee to work to get language put into the IGCC. So this is a process. This does not happen. This does not happen overnight. Working with the ICC, they update their codes on a 3-year cycle, which means you have to be engaged. Industry has to be engaged. Stakeholders have to be engaged early on in the process, and continue to work within the committees to advocate for the different codes. So we've begun this process. We have many industry advocates with us working through the ICC, the ICO process, to get this particular ACI 323 reference. So we're on that path. We're continuing to work that way. The codes themselves, the I codes in the U.S., obviously once they get referenced in a model code, you have the states and other jurisdictions who will then adopt those codes, those model codes. The states here in the U.S. are a little bit behind. So sometimes you'll see a model code will be out. Right now is, the ICC, the 2024 model codes. And many of the states are a few years behind, just starting to adopt the 2024 codes. So we're always kind of in this cycle of reaching out to the different jurisdictions. But that does not mean education does not start. We're already starting to reach out to different state authorities, letting them know of this code, that it's out there, and that we're hoping in working to have it referenced in our model building, in our model International Green Construction Code. Matt alluded to this, the general building codes. Um, we also look at the state level, but what we see, I believe, and it could be true in other countries as well, is a lot of the green or codes like our ACI 323, a lot of the interest in these type of sustainability issues, a lot of times rise from the grassroots. We see many states as well as cities, major cities, townships, local municipalities, really kind of moving the wanting to look at adopting these type of codes or standards to help address their goals of sustainability. So we kind of are working in two ways. I have the arrow up and down because as ACI is working on the national to get this particular standard adopted on in the model codes, we also are looking for opportunities and supporting folks on the state and local levels to possibly directly reference this code within their local ordinances. So just keeping that in mind, there's a lot of different levers, and it kind of depends on the way the state or your country is organized. But just know, grassroots is a way is another way of gaining momentum. So for support on a model code level. So how we do this, we look at partnerships. Partnerships are key to getting any type of code like this adopted, referenced, used within, model codes or specifications. And ACI has put together a program where we put together what we call collaboration groups. You can see here on the slide we have model code collaboration groups, which is the groups that are helping us on the model code level. We have state initiatives. So if we have specific collaborators in specific states in the United States, we will definitely go and work with them in that state to have this code directly referenced. We also have international adoption collaboration groups. We don't have a lot of activity yet in this area, but we have a system set up where we can collaborate with international organizations to help them form groups and help them with language and helping them, where will this code directly fit in with their particular country. So just know that's there, and we do have folks ready and available to assist on international adoptions. Matt's done a little bit of work on this. He's done some education internationally with other groups other than in Australia. I think, Matt, you've been to what, Japan, and the Middle East and some other locations, I
Yeah.
believe, where we're hoping to partner to have folks look at ACI 323 for adoption in their uh, building codes. So this is in place. I've also just wanted to bring this to your attention. You may or may not have known this. So ACI, again, we're an international organization, but in Australia, there is the Concrete Institute of Australia. So they do a lot of the same work that ACI does on an international level and in the U.S. But what we do have with CIA is a memorandum of understanding. So we work with them on many things. They have um, persons at their organization who sit on and follow some of our committees. We do collaborative agreements with them, obviously because worldwide there's a lot of experts all over, and we want to make sure that everything is being addressed in the concrete world with all of these experts. So we do have this agreement and great working relationship with CIA. We also have a collaborative working agreement with the Cement, Concrete and Aggregates of Australia. So they're a group representing the ready mix industry within your country. And I bring this up because in any way, in any type of movement to get standards adopted, collaboration is key. And these are key industry partners in your country that ACI works with, and that I feel if you were looking to move forward and have something adopted specifically in your country, these would be key organizations that you would need to collaborate and reach out to. Um, I also just did a little bit of looking at what your national construction code is. And Australia obviously has the Australia Building Code Board, which sets up your building codes on behalf of your government. And it appears to me, and if I correct me if I'm wrong, that each of your territories and governments have to adopt the National Construction Code. It is a prescriptive-based code, which is excellent in that it encourages innovation and allows for a lot of flexibility. Just knowing that, I'm sure some of you may know that, but from my perspective as a code engineer, it leads to innovation and for a lot of collaboration. So that's a good thing. It also includes detailed specifications. So when we're talking about adopting a code such as ACI 323, there's a lot of opportunities, I believe, in your country in that it could be adopted with language put directly into the building code. There's a lot of different sections I noticed on energy performance and sustainability where I think it could be fit in nicely, as well as in detailed specifications that are addressed within the National Construction Code of Australia. So what I did note and find, because this is something I look for wherever I go and look for possibly locations for it to be adopted, is the NCC allows for proposals to be introduced at any time. So although your codes in Australia are updated on a 3-year cycle, the NCC is updated on a 3-year cycle, similar to what we do in the United States with the I codes. They allow for submittals and for collaboration and work within their organization at any time. So that gives you a little more freedom in that you can approach organizations can approach NCC and start to collaborate and work with them at any time. So the key is determining where within your national building code language to address a low carbon concrete code such as ACI 323 would fit best for you, for everybody, for the code folks, for the industry, and for the design professionals. So that's a collaboration that kind of has to start early on if you want to look at adopting a code such as ACI 323. So that's all I had. I wanted to just kind of lay some of the framework out there and hopefully generate some questions within the group. So I'm going to just come out of this code. So thank you.